I tried this over the summer with my summer class. Yeah, students tend to like it. So they say that they get to watch the videos again, listen to lecture again. So hopefully it's helpful. All right. How's everybody? Okay. Quick question. What did you do over the break? Over. Anyone have class in the middle? Only one? Only one of you? Okay, some of you have class in the middle. So most of you, what did you do? Find a good spot to take a nap or no? No, that technically that is one of my endeavor during the time as a student. Find a place to sleep, literally, during the class. Uh-huh.
Yeah, I ate a burger and took a nap.
Take a nap. Okay, there you go. Okay.
I also ate food.
Yeah, ate food. Yeah. I remember there was one time I ate and too much carb. I have a carb shock. I overslept the whole class. Okay, I supposed to come to the second class, but I overslept. I wake up, the sun is down already. Okay, so yeah, yeah. So it happens. All right. Okay. So for me, actually, I just had another class. Just finished another class, Math 112A, the algebra one. Okay, the very basic one. Yeah, I just finished that class. Okay, and I have a couple minutes break. However, starting next week, during that break, it will be I will host office hour. If you look at the office hour, it's from 3:20 to 3:50. Okay, so there will be a good chance you come in to my office hour, see me, try to finish my lunch. That's usually my lunch around that time. Okay, so bring some food too if you want. Yeah, come and have fun. All right, so we finished 9 chapters. It's in Cal 1. All right, Cal 1, Cal 2, chapter 1 to 9, chapter 10. Okay, same book, Same book. Okay, vector and geometry of space. Okay, like I said, everything about this class is right here. Everything is here. So you're gonna see me make a lot of reference. I keep reminding you. Okay, in Cal 2 we have this 2D, we have this kind of formula. Now in 3D, you just add another coordinate. You add a little bit more, you have a different form, similar formulas. Okay, for example, distance between 2 points in 2D. I think you know that, right? You don't know the formula, but you know what I am talking about, right? The distance between 2 points in 2D. Now bring that up in 3 dimension. The distance, what would that be? In 2D, we have a circle, equation of a circle with the center, some point, right? X squared plus y squared equals something, r squared. That is the equation of a circle. In 3D, now we have a sphere. Okay, so you're gonna see that a lot. I make a lot of reference. I recall a lot of things from 2D. Okay, so consider, why do we learn that? Why do we learn 3D? And this is actually, in this class, you're going to see a lot of application. In Cal 1, Cal 2, you see minimal application of real world problems. In Cal 3, you're going to see that a lot. Okay, many problems I bring up, you're going to see that, actually in real world, that's how they do the math. Okay, that's how you get those numbers. Okay, so consider that you work in R&D department, okay, research and development at DJI, where you develop Tron models. I think you know DJI, right? Do you know DJI? Some of you tech guy. DJI is really good, actually right here. I'm using the microphone from DJI. They really popular with Tron. Okay, they are the pioneer in making Trons. And until the US start banning them, right? Until the US. Do you believe that in Canada and some state in America, you need a pilot license to fly drones? Yeah, in Canada, you literally have to learn the whole book and take classes. Technically, you learn every knowledge like a pilot, but you don't actually do the pilot. You don't pilot the actual plane. You just control the drone. But you have to have that license in order to operate a drone legally. And actually, still people have to do that because that's their profession. They do drone videographer and other thing. But seeing that announcement, a lot of people have to go back to school to learn the license. Okay, so and DJI is really popular in making that. Actually, they're the best in there. Okay, so if you are in that department, okay, you're making a new drone, what do you need to pay attention to? If you are in the R&D department, okay, your job is to, huh? How they're gonna move? Okay, good phrase. But now, eventually, all of you are gonna be in some kind of STEM major. I want to use more technical vocabulary. Okay, so how are they gonna move? Convert that to more technical words. Try that. Try again. Try that again.
How they're gonna race off the ground?
Up and down. So that is pinpoint the location, right? Location or position. And you just raise your hand, right?
Gravity.
Gravity. All of this involve 3Ds, okay? 3D, some kind of 3D. Angles, right? GPS. How do they communicate with your phone? Everything there. Location, position. We cannot talk about both of these without mentioning the velocity. And when you talk about velocity, rule of thumb, you have to derive the acceleration. Okay. Okay, and many more. Okay. All of this happen in 3 dimension, right here in the air. And in the air, how do you pinpoint those location, exact location right here in the air? You have to use 3 dimension, right? 3 dimension describe 3 dimension objects, okay? And that is what we have here, Cal3. Okay, so in short, we want to describe a 3D or 3-dimension space. In 2D, we use the XY plane, right? Okay, or XY coordinate, right there, okay, to describe a position with 2 axes, X and Y, obviously, okay. In 3D, we introduce a third axis, okay, and I believe you can fill in the blank, a Z axis, okay. Okay, very common thinking. Let's think like this. If X axis represent the direction, front and back, right? Y axis represent left and right. What do you think Z axis represent?
Up and down.
Up and down. Correct. Up and down direction. Okay. Any questions so far? Today a lot of introduction, so not a lot of math today. Okay, so similar to XY plane, which has 4 octants. 4 octants. I believe you can recall that that vocabulary, that word. This is the first octant, second, third, and fourth, right? Y, X, there, right? How about X, Y, Z? How many? For 3D.
6.
Okay. Some more? Okay, 8. Any other numbers? Try to think about it. Try to visualize that in your head. Okay. The right here? Okay. This is the positive direction of X, Y, positive of X, positive of Z. So if I prolong them, to the other side, that is negative, right? Negative. Okay, if I have that, and if I divide them, how many? 8, right? Okay. In 2D, each point represented by a pair of coordinates x and y, right here. That is x, this is y, so this coordinate is x and y. Right? Very simple, right? In 2D. Then in 3D, or actually the collection of on these points formally is written like this. X and y, they go a pair, given, okay, this straight line is read out, given that x and y are real number, okay, and all of these set are in R2, that means 2D, right here. Real number, this is the set of real number, that R is the set of real number, this is the set of real number, but in 2 dimensions, okay. Recall a few notation for the set. This is real number, right? All number. Natural, right? Right? Rational. Imaginary, right? But all of these are in 1D. When you write out this number, you have this line, right? This is R, all number in here is R, right? Real number, R for real. Then you have R square, all number here, all number here, all of this. Yeah. Make sense? Okay. Then each point in space, okay, instead of okay, this is not space yet. This right here, the xy coordinate combined, you have a plane, right? You have a plane, a surface, a plane. But in 3D, that point, if you move it out here, this is a space. So 3D you call space, 2D you call plane, right? Okay. So each point in space, we cannot use the word carelessly, huh? So each point in space, that means, aka each point in 3 dimensions can be represented by the order of the triple x, y, and z coordinate, right? The collection of these points, similarly, written like this, they go in a triple x, y, and z, given that x, y, and z are real number, right? Belong in a real number, okay? And all of this inside an R3, okay? Okay. Okay. Now, a plane in 3D. A plane in 3D is a two-dimensional object. Why is that? Plane. Here, space, right here, the air, right in front of us. That is 3D clearly, right? This is two-dimensional object, right? Right. Okay, if I hold it like this, up and down, left and right, there's no front and back, right? Too thin, right? So it's two-dimensional object. Okay. Because two-dimensional, that D, aka is dimension, another word can use for that D is 2 degrees of freedom. Okay. In statistics, we use this word more often, but in here we use dimension. But vocabulary is still called degree of freedom. Okay, DOF, degree of freedom. DOF. Okay. All right. Let's plot a few. First functions, a few functions in 3D. Okay, starting with y equal to. Okay, let's plot that. A few of them. Y equal to. Usually, when we do this, try to plot that in 2D first. Okay, plot that in 2D. See how it turns out. Okay, there is no eraser. Okay, see a piece of paper. Oh, that's good. Okay, in 2D, if you have to plot y equal to, what is that? Anybody? In XY plane. Horizontal line at y equal to. Okay, not my lucky day. X, Y, 1, 2. This is y equal to. Move that in 3D. What do you have? Shift that to 3D. What do you have in 3D? A plane. That first one, that is a plane, correct? At y equal to. How do you draw that? Try that on there. Try that. Okay, so now you're going to draw a plane at y equal to 0, 1, 2. Draw that. Okay. A plane at y equal to. Okay, in order to draw them, usually you have something to make reference. When you draw a plane, you draw something. You try, the best way you make reference, try to look for something that is either perpendicular, okay, orthogonal, or parallel. What do you think this this plane y equal to, what do you think about that plane? Does it perpendicular to anything? Does it parallel to anything? That plane y equal to.
It should be parallel to the x, right?
Right, x. In here, the line y equal to parallel to the x-axis. Therefore, the plane, if you zoom it out in, okay, shift it out in 3D, okay, it's just a plane. Okay, let's look at this one. If I draw like this, where is the z-axis? Like this, right? Exactly like this, right? An axis that poke out throughout the ball, right? Right? Orthogonal to this ball. Then this line in 3D prolong out into a horizontal plane like that. And also parallel to this x-axis. Okay? So, parallel, I try to something like that. All right. Z equal -3. I think you know that, right? A plane at z equal -3. Okay. -3. Down here. Now it's become a horizontal, right? A horizontal plane. Right? Horizontal plane at -3. That also parallel with the y-axis. Okay, z equal -3. Okay, how about x equals 0? AKA 0, y, z. What do you think about this one? Try those two. Try this and that. Try that. Give yourself a couple of minutes. Try that. X equals 0. If you draw x equals 0, x equals 0. First of all, I'm going to give you an idea. Okay, a hint is going to be a plane. First of all, this is a plane. But where is that plane? Where's the plane? X equals 0. A plane exactly at x equals 0. X equals 0 right here. A plane is right here. Okay. Now I know the planes are going to be starting from here. But what can I reference to that? Refer to that? Parallel to, perpendicular to anything, or what is it? That is the plane that contain both y and z axes. Okay, finally, y equal x. Y equal x. First, you want to draw the line y equal x. Right, y equal x. In 2D, I'm drawing exactly that one over there. Yeah. Okay. Y equal x over there. Now, in 2D, it's just a line. In 3D, it becomes a plane. Again, one more time, it's a plane. Plane y equal x. So you just have to make it vertical. And at the same time, it contains the z axis in there, that line. Okay. The diagonal plane that also contains the z axis. Okay. Passing through the z axis. Okay. Any question? Can I move on? Okay. Distance between 2 points. Okay. Distance between 2 points. Okay. In 2D first. In 2D. And then in 3D. Okay. 2D, recall. If I have point 1, P1, P2, how do I write? Okay, how do I notate the distance between 2 points? How do I write that? Make a notation. Distance between P1 and P2. In 2D, for example, P1 here, P2 here. Is it enough? How do you make a notation about distance? Remember this? Right? Distance, put an absolute value. Okay. If I have P1, P2, okay, let's say X, Y, X1, Y1. Okay, the first pair of coordinate. X2, Y2. Okay, then the distance will be square root of, anyone? X2 minus X1 square plus Y2 minus Y1 square. Remember that distance formula? Okay. Okay. That was 2D. That was 2D. That's what we learned in Calc 2. Now you have Z. So can you write that out yourself? Try that. I think you know that, right? Okay. Something square plus something else square plus something else square. I think you can finish that. Okay. It's 2D, 3D. Anybody know the equation of that circle? The equation of that circle. In order to write the equation of a circle, you need two things, right? Two things to write equation of a circle. First is the center. Second is the radius. You need center. Radius, how much? According to that drawing. Pardon me if I'm not really good at drawing, but huh? One, yeah. Okay. So you have those two. Something else square plus something square equal something square. X minus 2 minus y minus 2 square equal the radius square 1 square. There you go. So that is the equation of a circle. Center here, radius here. Okay. So generally, if I have center A, okay, maybe give another notation. Okay, A, B, then the equation of the circle would be x minus A square plus y minus B square equal R square. Right? That's a circle. Think about it. Try that. How about a sphere? Circle in 2D, bring that in 3D, you have a sphere. Now you have this center, you have this radius R. Try that. Try to write the equation of a sphere based on those two. Try that. Why it's so hot in here, huh? Okay, so can somebody read it for me? Anyone? Equation of a sphere? Whenever you're ready. Go ahead. Anyone? You just have another coordinate. Okay, go ahead. Don't be shy. Go ahead.
It's everything in 2D, but just add the z.
Just add the z?
Yeah.
Okay, so let's start with the first one.
X2 minus x1.
X minus the center, right? The coordinate of the center. The center in this case is h.
H, yeah. X
So,
minus h.
okay, keep going.
Plus y minus k squared.
Good job. Last one.
Z minus L squared.
Equal.
Radius squared.
There you go. That's a sphere. See, a lot of similarity between 2D and 3D. You see here? Here. 2D, a circle. We don't have that. 3D, sphere, you have that. Okay. Okay. And that formally, okay, that is a collection of all points around H, K, and L that had the same distance R to that center. Okay. All right. Let's do an example. Show that the equation, that very long equation right there, is the equation of a sphere, and phi is center and radius. Okay. There are 3 requirements. First, show that it is a sphere. Second, phi center. Third, phi the radius. Okay, this is like a part A, B, C. One by one. In order to show that this one is the equation, right? This one right here is the equation of a sphere. What do we need? What do we want to turn it into? Somewhere, the answer is in here. The answer is somewhere in this ball already. What do you think? This one that represents a sphere. What do you need this one to look like? Look like
C minus L squared,
look like this one.
or that one.
Right? This is the equation of a sphere. Turn this one into something like this. Something square minus this. Something else square minus this. Then you have the equation of a sphere. And when in that process, your final answer right here, when you turn it into like this, these H, K, and L, and R, those 4 numbers, actually actual number based on this problem, right? That also give you the center and the radius. Okay, so our job, turn this one into something like this. Okay, so that at least we know where to start. Okay, 9. So let's do that. 9x squared plus 9y squared plus 9z squared plus 9, not 9 anymore, plus 18x minus 36y plus 12z plus 13 equals 0. Okay, so the goal is you want to have something like this. Right? You want it to be like that, right? That if it under like this, if under this form, you can conclude this is a sphere. And at the same time, these question marks are your center and radius. Okay. There's no calc 3 from here to here. Now it's algebra. How do you do it? How do you achieve this? There's a technique. And you know that technique. How do you do that? How do you do that? Okay. Notice this first one. This is x and some number, right? Y and some number. Z and some other number, right? So I see x here. I see x here. How about I group them? Let's group the x with the x, y with the y, z with the z. Okay? We are working toward this. From here, right now I have something like this. I want to turn into something like this. What is this from? This thing, what does it look like? What do you call this? This, a then a parenthesis, and then a square outside. What is that?
Quantity squared.
One of the word, another one is another one. Perfect square, right? The perfect square. Complete the perfect square. Remember that? Complete the perfect square.
That should be a z, right? I mean an x, right? Like 9x squared.
Oh, 9x. Thank you. 9x. X with x. Okay. All right. Complete the perfect square. But with 9, with 18, 9, 36, 9, 12. It's not easy. So how about I factor first? Factor x squared plus 2x. Okay. 9 x squared minus 4x. 9 z squared plus z coming out 4 over 3 z plus 13 equals 0. Okay. So at the end of the day, your job is to complete the perfect square from here to here. Okay. I don't think I would go into much detail. I'm just going to give you this identity, the perfect square formula. Okay. A plus B equal, expand that, will be A squared plus 2 plus, and if you have a minus, then the minus over here, right? Right now we have this. Every parenthesis is right here on the right hand side. Technically only 2 terms. You need a third term to pop this one up. Okay. I'm gonna add 1. Okay, I'm gonna add 1 over here because that give me this. Okay, I'm not gonna go too much detail to this, huh? Okay, because it's algebra. Okay. 9. Okay, x squared minus 4x. What would be the last number? What do you think? 4. Last one. It would be 4 over 9. Okay. Out of nowhere, I just add this number 1. But in fact, if I multiply in, distribute in, that is number 9. I add 9. I add 36. I add 4 over here. Okay, out of thin air. So I have to subtract to balance it. Right. So plus 13. At the same time, I have to subtract 9, subtract 36, subtract 4. Technically down here, subtract 9, subtract 36, subtract 4, and equal 0. There you go. When I do that, then I return this one. That means I didn't do anything to this problem. Okay, I didn't add any outside quantity. I add 9, I minus 9. I add 36, I minus 36. I add 4, I minus 4. So balance. Okay. But because when I do that, these 3 become, what do you think? Now we're ready to write out our final problems. That will be 9x plus 1 square, 9y minus 2 square, 9z plus 2 over 3 square. Okay, how about the leftover 13? Okay, that is negative 40, negative 49 plus 13. That would be 36. Negative 36 equals 0. Okay. We're almost there. Okay. Without saying that 36, that negative 36 will go to the right hand side. So plus 36 both sides. So I have 36 on the right hand side. But at the same time, these 3 numbers, 999, I divide both sides by 9. Okay. So actually, let's not go too fast. Rewrite everything first. Okay. There. Okay. Now divide both sides by 9 to clear out the coefficient. And you have the equation of a sphere laid out perfectly. Then from that, I believe you can label the center. Also label the radius. Okay, finish that. And we just did an example, and actually a problem in homework 1. Okay, homework 1, and I'm about to upload later today or tomorrow. In homework 1, there's one problem. This the number 3. Identical. I didn't change any number, same number. Okay. But make sure when you do that in your homework, try to do it again from scratch, from your memory, from your knowledge. Don't copy and paste, okay? Even though it's the same thing, everything the same. But try to do that again on your own. Huh? Okay. Okay. Any question? Good? Okay. Let's move on. That chapter, and that is section 10.1. 10.2, where is that?
In the second row.
Huh? On the second row? Oh, thank you. So 10.2 and 10.3, okay, they go together. Okay. All right, so we got exposed to the space 3D, okay? In 3D, we need some tools to do the math. First of them would be vector, okay? In vector, okay, before we go into vector, there are two concepts, two words that I keep, repeating over and over until chapter 13, which is our last chapter. I'm going to keep repeating, we'll keep asking you whether this is either a scalar, okay, let me change the color, scalar, or a vector. Okay, we're going to do math with both of them throughout four chapters of this class. Okay, so a lot of math with scalar and vector. We have to able to recognize which one is scalar, which one is vector. Okay, and scalar, what does it mean? For this class, it's just a real number. Scalar is just a number. Give me an example right away. An example of a scalar.
4.
There you go. Another one.
5.
There. More fancier. Okay. Any scalar. Go ahead. Scalar. Another number. Come on, guys.
4 inches.
Huh? Okay. Still 4. All right. Okay, we're gonna work. We're gonna have some work to do with your creativity. Okay, after this class. All right. Second one, probably new, probably old. If you've been doing some physics, you see this word, vector. A vector is a quantity that has both
Direction and magnitude.
direction and magnitude. Okay. For example, vector V is a vector that connecting 2 points from A to B, not B to A. Okay. So first of all, to tell you different, that is not the same with B to A. A to B is a different vector from B to A. In fact, A to B, how do I make it equal? How do I make it equal? How do I make it equal? Put the negative. Or you can put absolute value both sides. So then that will be magnitude. Okay, A to B equal negative b to a, or the length absolute value in this context. In this context, that absolute value of a vector, when you have a vector, you put an absolute value, you don't call that absolute value, it's called magnitude. Or the length of that vector. Okay. Okay. So two vectors are equal, or more fancier, equivalent. Okay. If they have the same what? They only be determined, okay, a vector only be determined by two things, direction and magnitude. Okay, so you have two vectors with these two. In order for them to be equal, they have to have the same direction and same magnitude. Okay. A zero vector, okay, actually, before we go on, okay, vector u right here, vector u right here. Can you draw somewhere over here another vector? Let's call that v, whatever the letter you want. Draw another vector that is equal to this. Try that. Just anywhere in there. Okay, by that definition, just draw anywhere in here, somewhere close by, another vector, okay, that is equal or equivalent to u, vector u. Okay, try that. Done? Okay, so the answer should be L, because V already used up there. Okay. Or K, continue from that. Right. A little bit off, but yeah. I'm trying to make it same length. Okay. Okay. Now, zero vector. Notate like this. Number 0 with a vector notation. Okay. Had a length of 0, obviously, right? But how about the direction of that vector? Direction of zero vector. The name gives you the answer. The names give you the answer. Zero vector has
Zero direction.
no direction. Zero direction, okay. Yeah. Okay. Okay. In 3D, component of a vector has 3 coordinates. Okay, it comes from x, y, z. Okay, technically x1, y1, z1. On the way go to x2, y2, z2. Okay, that vector is written like this: x2 minus x1. Okay, comma y2 minus y1, comma z2 minus z1, and close that. Okay. Some book, you can use this notation instead of using the inequality sign like this. Okay, less than or greater than. You can use this notation. Okay, same. Okay, it doesn't matter. All right. Instead of keep writing x2 minus x1, y2 minus y1, I write down u. Okay, u1, u2, u3. All right. Any question? Okay. Magnitude. Okay. We're going to work with this. We're going to use this notation to answer these two. Magnitude, or the length of a vector u. Okay, that vector u. A length of a vector u. Okay. In 2D, in 3D, the length. See? That's notation, the length. Okay, what do you think? The length The length of vector u. Okay. Hint, something you saw earlier today. Something you saw earlier today. Okay. A right here. B right here. X1, Y1, X2, Y2. Connect them. Put an arrow, a direction. Then you have vector u. U, the length of vector u. What do you think? In terms of A and B. In terms of A and B, what is the length of vector u? It's just the length of AB, right? Between A and B. What is the the length between A and B? That means the distance from A and B, right? What the distance from A and B? Right? That's the distance. But instead of calling it x and y, this vector u, okay, I can call that, use the vector notation u1, u2, okay, u1, u2. Then this will become u1 square plus u2 square. And that is 2D. That's how you calculate the length of vector. Length of vector, because when you talk about the length, you don't worry about the direction. Then become a distance. Right? A length is a distance. Okay? Don't worry about the direction. I think you can finalize this. Right? Finish this. Can you? You can, right? Okay. Okay. Finish that. Okay. Operation with vectors. That means what can we do with two vectors? Okay. We can add them up. We can subtract them. Okay, we can do a few things with them. Okay, so start with addition. Two vector. So vector, let's say vector u1 is u1. I mean, vector u is u1, u2, u3, v is v1, v2, v3. Okay. I think you can add them. I know that you can add them. But my question is, what is the result of this addition? Okay, what is the result of this addition? Does it give you a scalar or it give you a vector? A vector. A vector plus another vector become a vector. Okay. Which is u1 plus v1, u2 plus v2, u3 plus v3. Actually, that's basically right here. I don't know why. Okay, my note is a little bit off. Technically, it's that one right there. Okay. Okay. Therefore, if you have a scalar multiplication with a constant. Okay, this word is constant. Okay, I may constant C. Constant C. Okay, C times U give you a new vector. Okay, this here. A constant multiplied by a vector give you a new vector. First of all, the result is a vector, not a scalar. Okay, whose length is multiplied by absolute value of C. Okay, technically, you extend that vector, the length of that vector, or you construct that vector. Okay, depend on the size of C. It could be greater than 0, it could be positive or negative. Okay, if it's positive, then you expand or prolong U by C unit. Okay. But when C is negative, you construct it. But also, flip the direction by C unit. Okay. Remember, AB, or actually, instead of using AB anymore, okay, U, then negative U. I just multiply by 1, negative 1. Okay, multiply by negative 1. First of all, number 1 tell me that the length will be the same. But that negative, I flip the direction. Okay. Okay, how about you multiply by 0? Everybody can know that it is 0, right? You're going to get 0. But 0 vector or 0 scalar? That is the question. You're going to get 0. But in this class, we have to pay really big attention to 0 scalar or 0 vector. What do you think? I'm going to put the word scalar or vector. If you don't know the answer, look for the pattern. You have to follow the pattern. C multiplied to U, no matter the C. When you write this, that means no matter the C, because this is just a small case in here, right? This is a bigger case. And in this rule right here, this line right here, this definition right here, tell you that whatever the C multiplied by a vector, you return a new vector. So no matter the C, even when C is 0, you return a vector. Okay, oh yeah, down here, there is some, there is an example. So U right here, okay, around this much. So 2U, you keep the same direction, this direction, but the length double the length, right? And then multiply by negative a half of U. So I flip the direction down and chop that length in half. Okay. Make sense? Any question? Okay, moving on. All right. Okay. If U is non-zero, V is also non-zero. Okay. And U equals C times V. Okay. I'm going to write down result. But before I write down, think. What do we get? What conclusion can we make about this? Okay, the hint is geometrically. Geometrically. What do they look like between U and V? Okay. There is one thing you can say about this U and V, these two vectors. U and V vector. U here, V here. There's one thing you can put in the middle. When you get this, if you have this condition, if you satisfy this condition, okay. First of all, don't pay attention to these two. These two conditions tell you that, okay, U and V exist. Okay, it has some length. It's just not a dot. Okay, so that's what it tells you. All right, really obvious. But right here, if U equal C times V, U is a multiple of V. Okay, what can you tell about U and V? What do they behave? They are, if C is negative, they opposite direction. Someone just say something. Someone just said something. But the direction is give you an idea. Close already, really close. U and V, they could be either in the same direction, or they could be opposite. Somebody just say something. Someone just say something. Go ahead, say it again. Say it again. Did you just say that?
Opposites?
They could be either in the same direction or opposite direction, correct? But combine both of them. Generalize that. They could be like this. They parallel. In order to be the same direction or opposite direction, at least they have to be parallel, right? Two arrows, in order to be the same direction or opposite direction, the first condition is they have to be parallel. So that is the property. Okay. All right. This one I just showed you earlier. If C is -1, then you have the negative. Okay, it has a name too. Okay, that negative U is the negative of U. The name is negative of U. Very obvious. Okay, the name actually is a name. So it look like this. Okay. All right. So let's do an example. 2U minus half of V, right? 0.5. 2U minus half of V. Draw that. What do you think? Draw that. 2U minus half of V. 2U minus half of V. Okay, I'm going to draw 2U first. Okay, so U is about okay, actually, copy that, paste that, there, right, prolong that, double that, there, so that would be 2U minus half of V minus, that minus tell me that I need to flip V. Right. So V is right now like this. I flip it, so it's technically like that, but it go in this direction. And also that 0.5, that half, I'm going to chop that one down to only a half. So right here, just only this much with an arrow. So V like this. Negative 0.5 V. Okay. Combine both of them. You have the middle vector in the middle. Okay. 2U minus 0.5 V. Okay. Some properties, this one we just mentioned. When C is a constant, the product of a constant, a scalar to a vector, you're going to return another vector. So technically you distribute. You distribute this C into U1, U2, U3. So distribute that. Okay, mathematically, that's what you do. What we did above, everything above, is try to visualize. What does it mean by doing this? Literally, you just prolong that vector, or you construct that vector depending on how big or small the C. And also tell you the direction after you multiply. It could be flipped if you have a negative. And you flip the vector. That's it. Okay. If you have, okay, what does this mean? What does this mean? What does it mean?
Magnitude.
Magnitude of C times U. This is still a vector, right? Right here. CU, C times vector U, that is still a vector. That is magnitude of this vector. Okay. You can split it out. That is magnitude, actually the absolute value of C multiplied by the magnitude of U. What does it say by this line? This line tells you that you can distribute a constant inside. You can distribute a constant inside. This one tells you that you can factor a constant outside of a vector. That's it. Okay, and you do that a lot. Technically, this one right here. Very often that you see this. Phi x plus phi x 10y 25z. Okay, and later on you're going to multiply this vector to another, like cross product, dot product with another vector. dealing the math with these number are not easy, right? It's big, kind of big, right? You can do this. They are the same. Can do the math with this. After you finish, multiply by 5. Okay, so that is what actually will happen right there. You can distribute a number, you can take it out. Okay, unit vector. Unit vector of u is just vector u, actually with the length 1. Unit vector, the word unit tell you that it is 1. Okay, the formula is u divided by its magnitude. Okay, u divided by its magnitude. Given that if u exists and u is non-zero, given that the condition is u is non-zero, because if you, why is that? Why do we need this?
You can't divide by 0.
You cannot divide it by 0. If this is 0 vector, then 0 vector has 0 length, right? You're going to put 0 here. Then you are going to divide it by 0, which is not good. Okay. Phi unit vector of u. Try that. How much is it? Try that. Okay. Give you a couple of minutes. Try that. Okay. Just tell me when you finish this problem. Your answer again. I'm going to keep asking you this question. The answer to this is scalar or vector? Scalar or vector? Vector, right here the question. Phi unit vector. So you're gonna the answer first one. It has to be a vector. Okay. So u unit vector is u divided by the length of u. So you have 1, 1, 1 divided by the length of u, which is the length of this one.
Is it just the square root of 1 squared plus 1 squared plus 1 squared?
Correct. Which is square root of 3. Which is 1 over square root of 3, 1 over square root of 3, 1 over square root of 3. And that's it. You have a vector. And that is the unit vector of this one. Okay. Okay. Some other property. You have interchangeable property. That means you can flip v plus u plus v equal v plus u. Okay. You add two vector. One of them is 0 vector. You return the same thing. Okay. This plus negative of u is 0, right? 0. Vector plus vector give you a vector. You can distribute. Okay. You can also distribute like this. Okay. Very basic algebra property with vector. Okay. You can C times D times U. Okay. 1 times U is just U. Okay. Very simple one. Okay. Standard basic vector. Standard basic vector. Okay, these are the foundation vector. That's another name for this vector. They are the foundation vector with the unit is 1. The length also 1. Zero, 0, 1. They are right here. I, J, K. They are the vector pointing in the direction of the 3 axes. Okay, first of all, standard basis vector. You can drop the word standard. Okay, basis vector. Basis vector are 3 vector. What are those? They are 3 vector that pointing in the direction of the 3 axes. What's the length of them? Exactly 1. Okay, that's it. Basis vector point in this direction. The length is 1. Okay, and we can often write the order vector. Every vector can be represented by the combination of I, J, and K. Technically, it should have vector like this, I, J, and K. Okay, so normally we can write like this, right? 2, 4, and 6. Instead of writing like that, another way of writing is 2I plus 4K plus 4J plus 6K. Okay. All right. Let's finish this example. We can call it a day. Okay. Finish this example. Just try that. Okay. Actually, the quicker you finish, the quicker we can count it a day. You tell me the answer for each one of them. Tell me whether these are scalar or vector. Okay. First one, x squared plus y squared. Scalar or vector? Scalar. X squared plus y squared times the basis vector. Vector. Okay, that's basically a constant multiplied by a vector. Third one, that notation. A vector, clearly right here. This the one, the giveaway. The vector. Okay. Third one. Scalar. Fourth one. Vector. Good job, good job. Last one. Think. Okay, now, vector or scalar? Are you sure? Are you sure? Vector or scalar? Are you sure? Vector or scalar? It's vector. I'm just testing you guys. You fail miserably. One more thing in my class. Be confident. Okay, trust your instinct. All right? Okay, so Ibrahim. Patrick. Clara. Maricus. Hector. Hector. No. Frida. Robert. Arlene. Arlene Garcia. No. Jonathan Garcia. Jocelyn. Joshua. Andrew. El. Julio. Amanda. Estela. Felix. Bernardo. Daniel. Thank you. Ibiho. Huh? Ipti. Okay. Victor. Jonathan. Gabriel.
Here.
Rocky.
Here.
Adrian.
Here.
Josie. Aaron.
Here.
Adam.
Here.
Kayla. David. Angela. Krista. Akash.
Here.
Thank you. Okay, see you on Wednesday.
Thank you, Professor.
You're welcome.
Oh, you're in? Oh, yeah, no, I forgot. Yeah, it's right,
This is like towards the. Like
I emailed you, by the way, for the.
Okay, okay. And how does it turn out? How does it work out with the?
So-
What do they say?
Because I have to, so when I go home now, I have to fill out like just some paperwork and email it to them, and they said it should take like a day or two for it to like reflect on my account.
Okay. And do I need to email anyone? You email me. Okay,
I'm not
I
sure yet. I
received.
might have to email you again because I'm just waiting for the poll to be taken off my account.
Okay, so right now I'm gonna be idle, huh? In idle. Whenever you need me to email anything, give me a heads up, okay?
Yeah.
Okay.
But I mean, I'm still good to show up to like Wednesday's class.
Yes, go ahead. Feel free. Okay, drop in.